Hello guys, welcome to our next topic, which is measures of association between two variables. So the relationship between two variables is very important in decision making. Thus we need to study covariance and correlation. So we have here guys our data for table 18. Um, this is the relationship of the number of commercials and the sales volume for every week. So there are 10 weeks. There are 10 weeks, week 1 to week 10, and we have there the different number of commercials and also the sales volume. For example, in our week 1, we have 3 commercials and it produces around 51, no? That is 100 100s. So, and for week 2, 6 commercials and 62. So we want to know if whether the number of commercials increases, the sales volume also increases. So we are going to compute for that. How to compute for that would be, we are going to have this particular formula. Okay, so by the way, this is the sample scatter diagram for that computer equipment store, wherein you have the number of sales and the number of commercials. And as you're going to look at the data, you can see there that there's a progress. No? There's a progress on the data. There's a positive relationship on the data.
Sir, ako hindi ko ano kay wala para ba si engineer ako ang wala pa na puman ako ang certification.
Okay, so this is now the scatter plot. No? As you can see, as the sales, as the number of commercials increases, the number of sales increases. So we are going to compute right now how to compute for that, for our sample, for our covariance now. So you have here for a sample of size n with observations x1, y1, x2, y2, and so on. Sample variance is defined as follows. So this is the sample variance. Sxy, S sub xy, summation of xi minus the mean of the x, and yi minus y, the mean of the y, divided by n minus 1. This formula pairs each xi with yi. We then sum the products and obtain the multiplying by multiplying the deviation of each xi from its sample mean x with the definition of the corresponding y I its sample mean y. This sum is then divided by n minus 1. So we have our table number 19. As you can see in the table 19, you have there our x. So we have our totals of all our x, no, and also the totals for all of our y. And here we subtract the value of xi by the mean. So the mean of this one, the totals is 3.2 divided by 32 divided by 10. So that's 3.2. So that is 3 minus 3.2. That is negative 0.2. Then we have 6 minus 3.2. That's 2.8. 1 minus 3.2. That is negative 2.2. 3 minus 3.2, negative 0.2. 4 minus 3.2 equals 0.8. 1 minus 3.2 is negative 2.2. 4 minus 3.2, that is 0.8. 2 minus negative 3 2 minus 3.2 is negative 1.2. 6 minus 3.2 is 2.8. 2 minus 3.2 is negative 1.2. So this is now our the result of our xi minus the x, the mean of x. And for y sub I minus mean of y, you have 51 minus 52.2 522 divided by 10, so that's 52.2, that is the mean. 62 minus 52.2, that is 9.8, and so on. So you have to remember, guys, that if you're going to add all of this for our x, that would result to 0. If that's not 0, there's a problem. Also with our yy minus y. And then after that, guys, is you are going to multiply negative 0.2 by negative 1.2, which is 0.24. Then 2.8 times 9.8, so that is 27.44. Negative 2.2 times negative 10.2, that's positive 22.4. Negative 0.2 times 2.8 equals negative 0.56. 0.8 times 2.8 equals 2.24. Negative 2.2 times negative 13.2, that's 29.04. 0.8 times 6.8, 5.44. Negative 1.2 times negative 4.2, 5.04. 2.8 times 13.8, 38.64. Negative 1.2 times negative 7.2, that is 8.64. Then after that, you are going to add all of this. After adding this, this one, 0.24 plus 27.44 plus 22.4 and so on, that would result to 138.6. Okay, so once you are going to have that, once you compute that, what you're going to do is you are going to divide that with 138.6 divided by n minus 1. So the n is the number of weeks, that is 10. 10 minus 1, that is 9. So 138.6 divided by 9, that is equivalent to 15.4. That is for our sample variance. So if we are going to compute for the population covariance, this is the formula. So you just simply change the value. You just simply change the value, no? Instead of n minus 1, you divide it with n. Okay, so let's proceed now to the interpretation of the covariance. Anderson et al. 2015 explains about how to interpret the covariance. Let us consider figure 15 to aid in the interpretation of the sample covariance. It is the same as the scatter diagram of figure 14 with a vertical line at x, which is 3.2. Okay, that is the mean 3.2, and the horizontal line y, that's the y mean, that's 52.2. The line divides the graph into 4 quadrants. You can, this 3.2 and the 52.2. So we have 4 quadrants: the quadrant 1, quadrant 2, quadrant 3, and the quadrant 4. Points in quadrant 1 corresponds to xi greater than x and y is greater than y. So if those are the data for in quadrant 2 correspond to xi less than x and y1 greater than y, and so on. Thus the value of xy minus x mean times yi sub I minus y mean must be positive for points in quadrant 1, positive for points in quadrant 2, positive for points in quadrant 3, and negative for points in quadrant 4. So this is now our diagram, guys. So if the value of xy is positive, the points with the greatest influence on xy must be in quadrants 1 and 3. So as you can see here, these are the points now, quadrant 3 and quadrant 1. Hence, a positive value for sy indicates a positive linear association between x and y. That is, the value of x increases, the value of y increases. If the value of xy is negative, however, the points with the greatest influence on xi are in quadrants 2 and 4. Hence, a negative value for xy indicates negative linear association between x and y. That is, as the value of x increases, the value of y decreases. Finally, if the points are evenly distributed across all 4 quadrants, the value of xy will be close to 0, indicating no linear association between x and y. Figure 16 shows the values of xy that can be expected with three different types of scatter diagrams. So you have the different three types of scatter diagrams, guys. This is positive, 3, 1, and 3. This is approximately 0, all the values present on all the quadrants. And this is negative, no? This is a negative. And x and y are negative linearly related. Referring again to figure 15, we see the scatter diagram for computer equipment store follows the pattern in the top left panel of figure 16. As we should expect, the value of a sample covariance indicates a positive linear relationship. That's 15.4. Is that 15.4, guys? Yeah, that's 15.4. That's positive. That's 15.4. Okay, so you know already that's how we are going to compute for our variance, no? Covariance. Then we have this next correlation coefficient. So person product moment correlation coefficient for sample data. So we have Rxy is equal to Sxy divided by Sx and Xy. So how are we going to compute that? The Rxy is a sample correlation coefficient. S sub xy is a sample covariance, which is we compute 15.4. Sx is sample standard deviation for x and sample standard deviation of y for sy. So let us show Sx. So this is our Sx, no? The square root of summation of xi minus x squared over n minus 1. So 29.6 divided by 9. That's 1.81. We solve for our Sx. And for Sy, we have yy minus y squared, no? This is an error, guys, no? So 697.6 divided by 9 equals 8.8. And then this is now how we compute our Rxy. We multiply 15.4, that is our value, and 1.81 times 8.8. So 15.4 divided by 15.93. Our answer is 0.97. Okay, so okay, so for population, that would be the answer, no? This is also the formula for the population. And interpretation. Okay, so for our coefficient, correlation coefficient, this Ramsey 2019 tells us about the correlation coefficient. The correlation coefficient R measures the strength and direction of linear relationship between two variables on a scatter plot. The value of R is always between positive 1 and negative 1. To interpret this value, which the following values correlation is closest to exactly negative 1, a perfect downhill, that is a negative relationship. Negative 0.7 is a strong downhill negative relationship. Negative 0.5, a moderate downhill. Negative 0.3 is a weak downhill. 0 is no linear relationship. Positive 3 is a weak uphill. Positive 0.5 is a moderate uphill. Positive 7 is a strong uphill. Exactly positive 1 is a perfect uphill linear relationships. So for our data, where Rxy is 0.87, we can conclude that there is a strong positive linear relationship between the number of commercials and sales. Meaning, you are going to increase the number of commercials. Because we are going to increase the number of commercials, the sales will also increase. Meaning, the commercials are effective. So you really have a budget for your commercials. So that's it, guys. So for your activity, you try to perform, try to compute how this particular information arrive. Okay, so I'm going to give you a number, sample number for our problem to solve this one. So for your performance, I'm going to give you a number, and this one. So take note on this particular diagram. This is a table. This is important. And I'm going to give you a sample data. I'll be using a notepad. So please excuse me for a while. Okay, so I'm going to give you guys the problem for you to solve. Okay, I'm going to change first. Okay, this one. Okay, so I'm going to give you right now a the data that you're going to solve, no. um, so as you can see, you cannot see, no. I'm going to change the setting of our okay. So as you can see here, this is our problem, guys, for your performance. So I want you to get a piece of paper, and you're going to compute for the sample covariance and the coefficient for this particular information. So you have week 1, week to 10, and you have the number of commercials and the sales. So what you're going to compute is you're going to compute for the sample variance of these two, and also compute for the correlation coefficient. So I want you to think after that, after solving, I gonna show you the solution, and you're going to check that based on our rubrics called PET. Okay, the PET is stands for performance, error free, and timeliness. Okay, so for our solution, guys, what we're going to do is we are going to add all of this data in our commercial. So we're gonna have two. Okay, um, 2 plus 4 plus 5 plus 5 plus 8 plus 3 plus 2 plus 10 plus 9 plus 7. So that is equal to 55. So you can now type that here below the this is 55. That's the total, no. That's the total. And by the way, this is our x, and this is our y, and we have our total. And the mean is 55 divided by 10. So the mean is 5 point x prime is equal to 5.5. And here in our sales, what we're going to do with our sales is we're going to add it up. in order to get our mean. So you have 50 plus 60 plus 90 plus 90 plus 120 plus 55 plus 50 plus 140 plus 110 plus 100. The total is 865. So 865 is our total, and our y prime, or the mean, is equals to 86.5. Okay, so once you have that, you can now compute for our you can add here another column for, okay, you can have that another column. Let's try to adjust the x. Okay, the x, you have the x minus x prime. Okay, so here sorry, the you will use a calculator for to solve that. You have 2 minus 5.5. It's negative 3.5. So you're gonna type here negative 3.5. Okay, then for 4, that is negative 4 minus 5.5. 4 4 minus 5.5, that's negative 1.5. Negative 1.5. Okay, 5 minus 5.5, negative 0.5. 5 minus 5.5, so that is negative 0.5. 8 minus 5.5, that is 2.5. 3 minus 5.5 is, kailangan guys, 3 minus 5.5, negative 2.5. 2 minus 5.5, that is negative 3.5. 10 minus 5.5 equals 4.5. 9 minus 5.5 equals 3.5. 7 minus 5.5 is 1.5. So, okay, so after that, you need to check whether our answers is correct. You can use a calculator to check that. You are going to add all of these. Negative 3.5. Okay, excuse. Negative, or is negative? Okay, dara. Negative 3.5, negative 3.5 plus 1.5 negative plus 0.5 negative plus 0.5 negative plus 2.5 plus 2.5 negative plus 3.5 negative plus 4.5 plus 3.5 plus 1.5. So the answer is 0. So that is correct. Our answer is correct. Okay. So for our y, let's try to adjust this one. Okay, let's try to adjust for our y. Okay, for our y, let's have y minus y prime. So that is 50 minus 86.5. 50 minus 86.5, which is our mean. Negative 36.5. Negative 36.5. 60 minus 86.5, that is negative 26.5. Then we have 90 minus 86, so that is 3.5. Okay, so the next is 90 minus 86 point 90 minus okay, 90 minus 86.5 equals 3.5. So you can also write here 3.5, and then 120 minus 86.5, 120 minus 86.5, that is 33.5. 33.5. Then 55 minus 86.5, 55 minus 86.5 equals negative 31.5. Negative 31.5. Then 50, that we already have here. 50 is minus 36.5. And then 140 minus 86.5, 140 minus 86.5, 53.5, 110, 110 minus 86.5 equals 23.5. 100 minus 86.5 equals 13.5. And to check whether this is correct or computation is correct, we are going to add all of this, and the answer, the total would be 0. So let's try to check. Okay, so let's start with negative 36.5 negative plus 26.5 negative plus 3.5 plus 3.5 plus 33.5 plus 31.5 negative plus 36.5 negative plus 53.5 plus 23.5 plus 13.5 equals. So that's 0. So that means our computation is correct. Okay, so we now already compute for our y minus y prime and also for our x minus x prime. So please check your paper if you got it correctly, no? Okay, so after that is we are going to multiply now our this value negative 3.5 by negative 36.5. Okay, let's try to adjust so that we could create our summation. Okay. Okay, so we are going to multiply this one 3 negative 3.5 by negative 36.5, and that is our value here is x minus x prime times y minus y prime, y minus y minus y prime. Okay, so let's try to adjust that. Okay, so this is now our value. So 3.5 okay, so you're going to multiply 3.5 by negative 36.5. So let's try to use a calculator for that. So you have 3.5 negative times 36.5 negative. Negative times negative equals positive. So answer is 127.75. So you have 127.75. Okay. Next, negative 1.5 negative 1.5 negative times, okay, let's try to cancel 1.5 negative times 26.5 negative equals 39.75. 39.75. Next is next is negative 0.5. Oh, excuse. Negative 0.5 times 3.5 equals negative 1.75. This is also the same. Then we have 2.5 times 33.5. 83.75. Next is 2.5 negative times 31.5. 78.75. Then next we have 3.5, which is negative, times 36.5 negative, 127.75. The next we have 4.5 times 53.5 equals 240.75. Sir, yes sir. Then you have 3.5 times 23.5, 82.25. And lastly, we have 1.5 times 13.5, 20.25. Then after this, we are going to add all of this one. Okay, so let's add. So we have 1 to 7.75, oops, 0.75 plus 39.75 plus 1.75 negative plus 1.75 negative plus 83.75 plus 78.75 plus 127.75 plus 240.75 plus 82.25 plus 20.25 equals so that is 797.5. 797.5. So that data is important to us in computing the our answer. So our SXY is equal to the summation of 797.5 divided by 10 minus 1. Oh, that's equivalent to how much is that, guys? Divided by 9 equals 88.6, 88.61. Okay, that is our SXY. And the next to compute is our R. Our R XY. So this is S XY divided by S X times x sa y. Okay. So we are going to solve for our sx and our xy. To get our sxy, you are going to um, that is 55, no? Square root of, what's the formula again? Let's try to look at our formula. Okay, by the way, that's our SXY, 797.5 divided by 10 minus 1. So that is 88.61. So let's go back to our formula of RXY. So as you look at the formula, okay, so this is the formula for our RXY. So we already solved the SXY. So we compute now the RXY. And the formula for that is this one. So the sample standard deviation of x and the sample standard deviation of y. So the summation of all xi and s squared, and what is the summation of that? So we are going to compute for our sx, guys, and what's the summation of that? Let's try to compute, no? Let's try to compute the sx and the sy. So this is the formula: square root of the summation of xi minus x squared divided by n minus 1. So we are going to have our table for that. We're going to compute for our x squared, the summation. So how is that? So let's try to look at the the x. This is our x, the summation of x minus x squared. So we are going to compute that here. We will add another, let's try to add another column, no? Let's try to adjust. Let's try to adjust, guys. Okay, so the square root of this one. So we're going to have the square root of the x minus x prime squared. Okay. Okay, so 3.5, that is 3.5 times 3.5. So we will use the calculator for that. I'm going to show now. Okay, I'm going to show now our calculator. So what we're going to do right now is we're going to multiply squared this one. Okay, we're going to square this one. That is important, to square the value of this one. So what is that value? That value would be the value would be negative 3.5 times 3.5 negative equals, that's 12.25. So this is 12.25. Then you have 1.5 1.5 1.5 negative times 1.5 negative equals 2.25. Then you have 0.5 negative times 0.5 negative 0.25. Again 0.25. Then you have 2.5 times 2.5 equals 6.25. So this is also 6.25 guys, as negative times negative. Then we already have the value here. 3.5 is 12.25. 4.5. So we have here 4.5 times 4.5 equals 20.25. Then we have 3.5, that is 12.25. Then 1.25 is 2.25. So we just copy the there are already similar answer here, so we just copy now. And then after that, you are going to add all of this. So we're going to add all of this. 12.25 plus 2.25 plus 0.25. Oops. 2.25 plus 0.25 plus 0.25 plus 6.25 plus 6.25 plus 12.25 plus 20.25 plus 12.25 plus 2.25. That is 74.5. And then we also need to compute for the yy squared. So where is that? We are going to put that here. Where are we going to put that? Okay, let's try to change our view, our setting. Try to minimize this to 18. Okay, can you see it? Okay, need to move the calculator first. So somewhere here I'm gonna adjust the number now. Somewhere here I'm gonna put some tab over here. Okay, 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 okay. So okay, okay, for this one we are going to have the y minus y prime, then that would be squared, no? So that is 36 negative 36.5 negative times 36.5 negative equals 1000. This is correct, guys. This is 1000 332.25. These are bigger numbers, no? Then negative 26.5, 26.5 negative times 26.5 negative equals 702.25. 702.25. 3.5 times 3.5, 3.5 times 3.5 equals 12.25. So here also that's 12.25. 33.5. 33.5 times 33.5 equals 1122. 1122.25. Let's try to move the values here. Okay, this one is negative 31.5, 31.5 negative times 31.5 negative equals 992.25. 36 negative 36.5 similar sa above, 1332.25. Then for the 53.5, 53.5 times 53.5 equals 2862.25. 2862.25. 23.5, 23.5 times 23.5 is 552.25. 13.5 times 13.5 182.25. By the way guys, you really have some patience, no, in solving. Patience is the key. Okay, so after that we're going to add 182.5 plus 552.25 plus 2862.25 plus 1332.25 plus 992.25 plus 1122.25 plus 12.5 plus 12.5 plus 702.25 plus 1332.25 equals 9,103. So that's the 9,103. 9,103. So to solve for our SX, SX is equal to the square root of what is our x 74.5 74.5 divided by 9. Square root. Symbol of square root, guys. The square root. I don't know the symbol. I don't know how to write the symbols, guys. Square root. Okay, square root. Square root of 74.5 divided by 9. Okay. And SY is equal to the square root of 9,103 divided by 9. Okay, so that's the value of this one, guys. This is equal to 74.5 divided by 9. 74.5 divided by 9. 8.27, 8.28, 8.28. Then 9,103 divided by 9 is 1,000. This is square root pa ni, guys, no? 1,001.44. 1,011.44. This is still square root, guys. Square root. This is still square root. Okay, so the square root of that is we need a calculator. Let's try to use a scientific calculator. Or is the square root? Square root. Let's see the square root, guys. Square root, where is the square root? Is this? Oh, this one, square root, no? So 8.28. Then click this one, square root. Square root of 8.28 is 2.88. 2.88. And then the square root of 1,011.44 square root 31.80. 31.80. So after this, so you substitute rxy is equal to 88.61 divided by 2.88 times 31.80. So rxy equals so 88.61 divided by 2.88 divided by 31.8 equals 0.967 0.97 equals 0.97. Okay, so our answer is 0.97, and this means, what does this coefficient correlation? It's a positive strong relationship, meaning there is a strong positive relationship between the ads, the commercial, and the sales. So therefore, you need to increase your commercial so that your sales will become higher. So I hope you get the correct solution, guys. And just a reminder for your grade, you have P. Uh, if you perform all the tasks, you will get 4. E. If you have perfect score, that would be 4. 3 if one mistake. 2 if two mistakes. 1 if three mistakes. 0 if more than 4 mistakes. And timeliness, if you submit it on time tomorrow on Monday, you will receive 4 if you did it early. Okay, thank you very much, guys. I hope you enjoy our very long tutorial for our subject. See you in our next tutorial. Thank you very much for watching. I hope you get your correct answer. That would be all your performance, no? We will no longer have our quiz, no? Thank you very much. Bye-bye.